Morning, everyone.
Morning.
I sent you numbers to try out. Did you try out the number for the UPDF missile launcher? Hello? Did you see that number for the UPDF missile? So these are more examples on projectiles. Example 1. A UPDF missile launcher, free to rotate through 60 degrees on either side. On either side of the horizontal line. Either side of the horizontal line. Through the muzzle in the forward direction is releasing missiles with muzzle speed of 49 meters per second at elevations between 30 degrees and 60 degrees. Estimate the area of the regions that can be hit by the missiles. Estimate the area that can be hit by the missiles. Now, we have two categories here. One is when we project with an angle of 30, the other is when we project with an angle of 60. And if you're to get range for 30 degrees, the range for 30 degrees R would be equal to U squared sine. Remember, range is equal to U squared sine 2 theta over G. So this will be U squared sine of 60 out of G. So the initial velocity is 49 squared sine of 60 divided by 9.8. What is that range? Come on, give me that answer.
$212.176.
212.176 meters. Then the range, when it is the projection is for 60 degrees. the range will be, this is R2, this is R1. For 60 degrees, it will be U squared sine of 120 because it is twice theta divided by G. This will give us 49 squared sine of 120 divided by 9.8. What answer do we get?
I'm getting the same answer.
What?
200. I'm getting the same answer, 212.1.
212.176. Okay. So that means if you're to project both using 30 and 60, you get the same what? You get the same range. But maximum range is good from which angle? If you call maximum range is good when theta is 45. So can we get range maximum? Range maximum would be U squared out of G, which is ideally 49 squared out of 9.8. Get 200 and this is 245. Now maximum range, if this is 30, this would be 60. Then 45 would be in between these two. And 45 takes us to the maximum range. So this gave us 245 meters. Now the question wanted what? Estimate the area of the regions that can be hit by the missile. Now the area, first of all, we have seen that if you look at the two ranges, if you have a sketch like this one, just to interpret the ranges. This is the area where the missiles can hit. It can hit between this space and the maximum range of the missile. Now that means if I have this as R1, range 1, because let me call this one R3. Then R3, it goes as far as this one, where the maximum range can be attained. And according to this, if you have this as 60, can also produce this too, because these are sectors of a circle. In case it is projected from down, whereby this is the horizontal line. This is the horizontal line. It can be projected, remember they say it can rotate through 60 degrees, the missile. So it can rotate through 60 here, and it can also rotate through 60 here. So if it's not the horizontal, you can also consider the horizontal surface, and it can be projecting at 60 on the left, it can also project at 60 on the right. So the angle between those two rotations is 120. Therefore, the area would be the area of the sector. So you get the area of the first sector with R1, get the area of the second sector with R2. Area of the sector is given by theta out of 360 times pi r squared. Now, because we have area 1, which is going to be theta out of 360 pi r1 squared, then you can have area 3, which is going to be theta out of 360 times pi r3 cubed. When you subtract the change in areas, you'll get theta out of 360 of pi into r3 squared minus r1 squared. But remember, these r's are the ranges. So we have range 1, range 2, range 3. But range 1 and range 2 are the same. So we can get the change in area as 120 degrees, which is the variation of the missile launcher. Divided by 360 times 22 out of 7 into 245 squared minus 212.176 squared. With this, you can get the area where the missile can hit. So compute that and get the answer.
Teacher, why are you using 60 and 60 on both
Because
angles of the?
You can see my image. Can you see my face? This is where the launcher is. The launcher can rotate through. It can rotate through this angle 60, so it can be projected at that angle. If it goes back to the vertical, it can also be projected and rotated through another 60. So the launcher has a maximum rotation of 60 and 60 on both sides. So the total angle between the variations of the launcher is 120. That's how the 60 came about. It was mentioned in the question. Okay. So what else have you get? Someone get us an answer. Otherwise, I need to
15,720.
10,000. 740.
720.
Sure. Exactly.
0.9329.
Someone else. 0.9329. Okay. Someone else check it out and see the answer also gave. Meanwhile, I can write down this other next number I want us to look at. I remember I sent you a boss talk. Those of you who have boss talk and you can open it, go to page 267. This is example 2. I sent, I think, all these numbers, but I don't know whether you tried them out. No one sent me a number. So as you see, a ball is struck at a speed of 25 meters per second from a point of 50 centimeters above the ground. When it has traveled 20 meters horizontally, the ball just clears a fence that is 3 meters high. Find the smallest angle of projection for which this is possible, and hence determine the further distance beyond the fence at which the ball hits the ground. This answer is 36.3458 meters. So here we are, we have another number. And this number is saying we have a ball that has been struck or that has been hit and as this person kicks the ball or hits the ball, we are seeing that it has been projected at some angle, but from some height. So if we are projecting the ball from a certain height, we can draw the height, look like this. Chifo. Baba 5 baba wakorako bulungi. So if you project the ball goes, comes and falls down. But when it has traveled some distance horizontally, they have said when it has traveled a distance of 20 horizontally, what is happening? The ball is clearing a fence. When it clears a fence, it just passes at the height of the fence. That's what it means. So if this is where the fence is, then the ball is clearing it. And the fence is of what height? It has traveled 20 meters horizontally at that instant. The wall is 0.5 meters from where it has been projected. It is projected at a speed of 25 meters per second. At what angle? At an angle of projection we don't know. Okay? Then we are saying the fence is 3 meters high. So this is 3 meters high. Now, when you look at this position of clearing the fence, the position of clearing the fence, the coordinates there are, they are coordinates of 20, 3. So I told you if you have coordinates or if you have the horizontal distance and the vertical displacement, the best equation to use is the equation of the trajectory, especially if they're asking you to find the angle. And I also told you one other thing, that this equation is also very suitable if they're asking you for the 2 possible angles of projection. Now with this, we can substitute y. Y is 3, whereas x is what? 20. On substitution, we shall have 3 is equal to 20 tan of theta minus g times 20 squared divided by 2 times 25 squared into 1 plus tan squared of theta. With these illustrations, we can go ahead and simplify. Can you get me this term? The whole of this term? Someone compute the whole of that term in red. Actually, before that, wait. They have said, no, I've interpreted this wrongly. When it is here, because this height is 0.5, it has so far traveled a vertical height of 2.5. Sorry, I missed this out. Because at this instant, it started from this level. So what height has it traveled so far? It has traveled 2.5, not 3. So this is 2.5. Okay, get me my term.
$774.320.
This term, when you divide, because you're multiplying 9.8 times 400, divide by 2 times 625. 625 is 1,250. So you are ideally dividing 400 by 1,250, then times 9.8. It can't be that value. It's slightly smaller than that.
$3.136.
Correct. 3 point?
136.
Minus 3.136 into 1 plus tan squared theta. So we can design a quadratic in tan. This will be 2.5 is equal to 20 tan of theta minus 3.136 minus 3.136 tan squared of theta. Therefore, 3.136 tan squared of theta minus 20 tan of theta plus, when the 3.136, a negative crosses over, becomes a positivity, so it will give me 5.636 is equal to 0. So that is what we have as our quadratic. So can we get the values of theta? Tan of theta is 1. Tan of theta is 2.
$6.0821.
We get 6.0821. Another one.
0.2955.
Okay, then what is theta 1? Shift tan inverse of the answer. Hey, excuse me. I have a class. Take your sound outside. Theta 1 is
80.66.
80.66. Then confirm theta 2.
$16.45. I mean 16.46.
Now the question said the smallest angle. So the smallest angle is 16.46. Therefore, the smallest angle of projection is 16.46 degrees. Now they have further gone and said, find the smallest angle of projection for this to be possible, and hence determine the further distance beyond the fence at which the ball is hit. Now the further distance is this x2. Okay? But now remember, when the particle is moving down, yeah, let us look for the total displacement x, where it will land totally. But because it is going below the point of projection or the level of projection, this is the level of projection. Yeah. What did we say? Shakira, when the body goes below the point of projection or level of projection, what happens to its vertical displacement?
It becomes a negative.
Becomes a negative, thank you. So it's a negativity of y is x tan of theta minus gx squared out of 2u squared into 1 plus tan to the square of theta. Now, because you already got this tan theta 2, which is this one, if you're a smart student, you don't need to substitute 16.4. Just go ahead and say, okay, the particle is going down, yes. What height is it covering? It is covering a height of negative 0.5, yes, is equal to x, which you're looking for, the total displacement, times tan of theta, which tan of theta gives us what? 0.2955 minus 9.8 divided by 2 times 2.25 squared into 1 plus 0.2955 squared. Can we get a quadratic in x? There is an x squared here missing. Another person may not use this equation of the trajectory and use the equation of vertical displacement. Then you find the time, then we find the horizontal displacement, as I'm also going to show you that. So this is the same as negative 0.5 is equal to 0.2955x minus. What do you get? 9.8 divides 625 times 2. Then times 1 plus 0.2955 squared. What do you attain?
Chichi Obi.
Guys, compute.
Now,
8.5246 exponent negative 3.
Exponent negative.
3.
Then this is x squared. Eh? So idea is the same as 0.0085 to x squared minus 0.2955x minus 0.5. This is equal to 0. Compute this solution and give me the answer using a calc.
$36.2998 negative 1.6167. Negative 1.6167. Teacher, you're muted.
Yes, I was saying the negative cannot be the correct answer. Okay, reason being, already we have a positive 20 meters ahead. Negative would mean you're going backwards. Now, and more so, it cannot even if you are to consider it's positive, you cannot say it is positive 1.617. Why? Because the particle so far has already traveled 20 meters past the wall. Now we are looking for the distance beyond the wall. So meaning the total distance from the start to beyond the wall where it lands should be greater than 20 already. So that's why this is the correct what? This is the correct displacement. So with that, the distance behind further will become 16.3 meters. Now, I told you that you can even use the other format of finding time by saying y is equal to ut sine of theta minus gt squared over 2. That because you already got the angle at 16.4, The negative displacement will be a negative 0.5 is equal to 25 times time we don't know, sine of 16.4 minus 9.8 times time squared. Okay, let me say this is 4.9 straight away. I've already divided. Someone get me the value of 25 sine of 16.4. We are just going to confirm whether we get the same answer, so that I show you another option.
Seven point zero five eight five.
7.0508 t. Now solve the quadratic, get me the values of t.
One point five zero eight one eight 1.508.
Yeah, that is
Negative 0.8677.
because this one is discarded. X is got from ut cos theta. So this is going to be 25 times 1.508 times cosine of 16.46. What answer do we get? Should be getting 36.1.
$36.1757. 36.17.
17. Which is approximately.
57.
You have just missed out some decimal places, but it is close to that. So ideally, I wanted to show you the two methods that you can use directly the equation of the trajectory, or you can use the vertical displacement, but still vertical displacement is a negative. Why? Because we are projecting a particle and it's going below the level or the point of projection. So we can have that down. So screenshot that. I show you another. This time round, I want us to visit the bus stop. There's a definition I never mentioned last time. When a particle is projected below the point of projection, what happens? So we have an example of that category here. When a particle is projected below the point of projection 1, if it is projected from this point O, then this is the level of projection. 1, the height is negative, like we have always known. Now, one special thing is this angle of projection, the angle of projection is a negative. So this angle below the horizontal, which is 30, is a negative 30. So look at this example. It says a stone is thrown from the top of a tower, which is 11 meters high and stands on a horizontal ground. The speed of projection is 12 meters per second, and the initial direction of motion is 60 degrees to the downward vertical. So this is the 60 degrees to the downward vertical. Find the time taken for the stone to reach the ground. Find also the direction of the stone just before it touches the ground. Now here, 1, you have to find the angle between the horizontal. This is the horizontal. You have to find the angle between the horizontal and the direction of motion. That angle is a negative. The angle is taken to be assumed to be measured as if you're moving. Remember, all students take cocaine in trigonometry. And when you move clockwise, angles are what? Negative. When you move anti-clockwise, angles are what? Positive. So in this case, we are looking at it as if you're moving in the clockwise direction. That is why theta becomes a negativity. So if I may look at this solution from up here, starting up here, you will have y is equal to ut sine of theta minus gt squared over 2. But because I've said it's going below the point of projection, y is a negative, so you'll have a negative. The speed of projection is 12 times the time you don't know, times sine of the angle below the horizontal, which is a negative 30, minus 4.9 t squared. With this can help you find the time. So the height is negative 11 is equal to a negative 6t minus 4.9 t squared. Since everything is negative, we shall have 4.9 t squared plus 6t plus 11 is equal to 0. Can you find the time? So the only important thing I wanted us to see here is whenever the particle has been projected, and this was initially the horizontal, and is being projected like that at a trajectory, then this angle is a negative theta, is what we consider. So what else did you get here? Oh, they said take, You see the question? It says take G as 10. If they say take G as 10 and you come and do like what I've done, you're going to take G as 9.8. You will be crossed. So this was supposed to be 10 out of 2. So this is 5. This is 5. Two numbers multiplied, you get 55. Added, you get 6. That is, I think they are not there. Would have been 6, 5 and what? 5 and 11, negative 5 and negative 11. But when you subtract, when you add them, you can't get a positive 6. So when you compute with the calc, what do you get? T1 and T2. So like I told you, we might solve a lot of numbers. It might even take us a month because I'm seeing time is flying here. We have around 15 minutes. And you have
negative 0.6.
Negative 0.6.
Negative 0.6.
Are you sure?
Yes.
Negative 0.6 and negative 0.6 are the answers we are getting. That is strange. These are the answers we expect. 1 and negative 2.2. Hey, no. Yes, my fault. I've seen it. When you cross over these two, this one becomes a negative. It remains a negative as the others becomes positive. So can you change it?
One and negative 2.2.
1 and negative 2.2. So t is 1 and t is negative 2.2. But this is discarded. So the time is 1. So if they have found the time for the stone to reach the ground, they have said find also the direction of velocity, direction of motion just before it hits the ground. Here, it is moving with the horizontal component Vx with the vertical component Vy. Vx is always got from u cos of theta, which is going to be 12 cos of negative 30. Cos of a negative is the same as a positive, so cos of root 3 over 2, and this answer becomes 6 root 3 meters per second. Then for Vy is always use sine of theta minus gt. So Vy will be equal to u is 12 sine of a negative 30 minus 10 times 1. So this will give me a negative a half, which is a negativity of 6 minus 10, giving us a negative 16 meters per second. Therefore, the magnitude would become the Vx, then we have the Vy going down, then you get the resultant, V. So the velocity is 6 root 3 squared plus negative 16 squared. What answer do we get? You can as well get, they said find the direction of motion. Actually, they never even asked for the velocity, but they asked for the direction. So I was just showing you how to get the velocity, but you can as well get the direction as tan alpha is equal to Vy, which is going to be now a positive 16 out of 6 root 3. With this, you can confirm what alpha is. Why I don't attach, why I do not attach the negative on this Vy, it's because the arrow is already showing us the direction of the negative. Okay? So someone confirm for us what alpha can be.
$56.9955.
What is that? The angle?
Yes, alpha.
56.9, okay, roughly 57. 57 degrees below the horizontal. So one key item we have seen on this example is whenever the particle is projected below the point of level of projection or below the horizontal, they are projecting it like this, like that. You consider this angle here, but consider it as a what? As a negative, right? So, we have a few minutes left. Now, the next week, the next lesson, I need to discuss numbers which are called simultaneous projections. So I'll ask you to go ahead, take that screenshot. I'll require you to get numbers which are projected simultaneously. I'm also going to send some so that you start looking at some of them. By the time we meet, you have an idea of what I'm talking about. Then after simultaneous projection, we shall go for proofs in projectiles. That one also require, okay, maybe we shall do some small 10 years. Next week, introduce proofs. Then the other week, we finalize proofs because proofs are very interesting. They're not as easygoing as some of these solution numbers. To require a lot of algebra, I'll require a lot of your trig, I'll require a lot of your indices in the proofs. So I'll expect people to have such ideas at hand. Meanwhile, let me also screen share some numbers here for you to take screenshots. You see simultaneous projections. This is what I was trying to say. Take this screenshot and look at these two numbers in the meantime. You just go through them. By the time I come to go through simultaneous projection, you have an idea of what I was trying to say. So screenshot that. But you also have Bostock, like I said. So the projectile topic is on page 267. So also get this exercise 9B. Try out the numbers. Like I told you, in A level, you're supposed to check yourself, to motivate yourself, to send yourself to solve the numbers. There will also be a discussion on these vector numbers, also screen share them. And I'll take a screenshot, I'll show you. Write down number 16 is one of the numbers I'll discuss next lesson. Then also write down number 17 is one of the numbers I'll discuss for simultaneous projection. Then there is another last exercise I want us to see here. Oh, before I can go to that exercise, there's a number here. I want you also to screen share and have it with you. Have this number, number 2. It's a proof, but in solution form. They are saying if there are 2 possible angles of projection, show that those angles of projection are that. So have that down. Then we shall also have, also screen share here, there is number 7. Yeah. There's number 9. Those are all very interesting numbers to look at. Then we shall write down this proof of number 14. That one it will be one of the proofs I will start with. Yeah? Number 14 is very good at being a question for proofs to look at. Number 15 is also an interesting number. Also write down number 19. Number 19 will also be my proof I will handle. It is simultaneous projection. Immediately after simultaneous projection, I'll start with number 19 for the proofs. So have it written down. Also number 18 is very good. Also number 17, take those screenshots. So all those numbers, guys, are quite interesting. And I'm assuming that I'm giving you these ones, but definitely you'll go for understanding mechanics without even my command. So please make sure you visit understanding mechanics as well. Then this is our best page for proofs. Page 289. We shall do, even if I don't solve all of them as a teacher, the rest will, those I will handle, I will handle. Those I will leave out will be yours. But we need to look at number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9. The whole of that page is full of proofs which are very interesting. So I want you guys to take a look at those proofs, write them down. I'll come and pick some few and handle them. Those who don't have the book with you in soft copies, take a screenshot. But I sent the book again, you can request for it, and I send you Bostock once again. Then lastly, we shall have these last numbers this way are normally for my students to take a look at. But also I'll bring Humphrey. There are numbers of Humphrey I'll also show you, which we shall look at in proofs. So these remaining 2 pages are yours to know that the world is not a joke. Trust me, if you do some 3 numbers on your own, on these 2 pages, you become a projectile machine. No projectile can handle you. So they are quite interesting. So the proofs are quite many. That's why I'll start them next week and then finish them in the other second last week of November. in the name of saying we have done projectiles to maximum, and we shall do all the concepts concerning projectiles as per the examples. Unless if someone has a question. If no question, allow me to stop
I
here.
have a question.
Yes, please.
On the first page, on the first example we did,
Hmm.
why is your diagram appearing like that yet the angle is 160?
This one.
Yes.
Why is my angle what?
Why is your diagram appearing like that yet the summation of 60 plus 60 is 120?
On this diagram,
Yes.
now, look here. I can project the missile like this through an angle of what? 60. Not so. I can also project the missile like that through an angle of what? 60. So if the missile goes like that and it goes like that, then it is going to cover this range. This is where the missile can hit in the two possible ranges of the angles. So the entire total, because they told us the missile could oscillate, could rotate. They said a missile launcher free to rotate through 60 degrees. So it was free to rotate through 60 what? Degrees. So if it is free to rotate through 60 degrees, it means it can rotate through an angle of 60 on this side and an angle of 60 on the other side. So it has a total rotation angle between the ranges of rotation of 120. Have I made more sense?
But they said 60 degrees on either side of the horizontal line.
And Kat, I
And
told
you're 60.
no, I told you
Look
this
like
is my
the-
horizontal line. That vertical, I've just used it for explaining. I'm showing you, I showed you, remember I said this was my horizontal line? You remember that? Even I wrote it down here that this is my horizontal. So in the horizontal, we have a 60 on this side, we have another 60 on that side. So if the horizontal is like this, okay. This is the horizontal. Do you agree? I mean, I think you want this one, which is level, or which is the x-axis. It is rotating through this way at 60 degrees, not so? It is also rotating through this way. No, if it is rotating through 60 degrees on either side of the horizontal, then it means the angle between here is 120. If it is the angle between there is 120, then the remaining angle here is 30. Then this one is also what? 30. But if you divide it evenly, this becomes 60 and this becomes 60. Yep. Hello, are you still there?
Yes, teacher.
Is that better?
Yes.
Okay. You have a good morning. Please try out some of those numbers. It's okay. Try it is very healthy and very encouraging to me to confirm that my learners are participating. If I said try those numbers, you try them out, send them to me. I help you here and there. I say try this. It is very interesting. Trust me, when we come to proofs, the life won't be easy. But if you get there when you're ready, life will become simpler. But if you just join a lesson just like that for just to join the lesson, when you've not been preparing yourself to come for those proofs, there will not be any interesting to you. Okay? Okay, so with that, allow me to stop here and have a good morning.